Thank you very much. I'm delighted to be here. It's very exciting because officially this is the first public release of the results of this study. So we are very pleased about this. And I'm here along with my colleague, Professor Maksimovic, to talk to you about these findings. We still consider them somewhat preliminary from the University of Colorado's field study of plug-in hybrid electric vehicles in a smart grid environment, sponsored by Toyota. This is a unique study and the only one that we know of its kind. The presentation is in three parts. First, an introduction to the research, attitudes toward the vehicle, and key findings on feedback and charging management, which were core concepts in the study. And then vehicle and smart plug findings on driving and charging, performed by Professor Maksimovic. And then a part three on ongoing analysis and preliminary conclusions from the study. Now, just a quick overview of Boulder for those of you who might not have been to Boulder or not know too much about it. It's a town of about 100,000 residents located at the base of the foothills about 25 miles northwest of Denver. It's the home of the University of Colorado with some 25,000 students and 2,000 faculty and staff. And the city leans toward the liberal end of the spectrum, I would say, and prides itself on its environmental concern. Because of a 1964 vote for a sales tax to buy lands, Boulder is surrounded by open space, and therefore it has created a self-contained city. It was the first city in the United States to vote in on itself a carbon tax in 2006. And a majority of the Boulder residents favor renewable energy, and several solar business startups are located in the community, which has actually, it's quite a clean tech incubator. The city is located at 5,430 feet and has approximately 45,000 households. Okay, so data collection for the vehicle study began in October of 2010 and ended at the end of May of 2012. It's important to note that the vehicle study was not conducted in a vacuum. While the study was going on, relevant events were happening in the Boulder community that you may already be aware of, including the build-out of Smart Grid City and a vote on municipalization of the electricity supply, which, by the way, passed. These occurred in 2011. These events could have had some effect on the PHV study results, although we cannot specifically measure what these effects might have been. Now, an introduction to the research. Toyota ultimately provided us with 28 2010 plug-in Priuses to the university for field testing. These vehicles had a 14-mile range and on electricity only, and then they seamlessly moved over to the hybrid mode. Toyota was interested in testing cars in a real-world environment, real-world situation with altitude, terrain, and temperature ranges, that is -20 to 104, that challenge batteries, and as well to gauge the effect of feedback on vehicle charging behavior in a smart grid environment. Xcel Energy, which is our local utility, partnered with the research in order to assess the effect of charging behavior on the utility grid. Xcel installed smart plugs in participants' garages for plugging in the vehicles. These would keep track of vehicle electricity usage at the home and provide feedback at a website. So we selected the study households randomly from two lists, both of which had smart meters. One, the households with standard pricing who had volunteered for Smart Grid City early on and had given permission to Xcel to share their names with the university for research purposes. Now, at that time, nobody knew there was going to be a vehicle study. And the second list was volunteers for time of use pricing, which is still strictly voluntary in our service territory. And these people had also okayed the use of their names for research purposes at the university. Note that this is not a representative sample of the city of Boulder. The research design was driven by a 4-cell table with pricing scenarios as the column heads and charging scenarios as the row heads. Here are the pricing variations. And as you can see, some are on-peak pricing. For us, 23.2 cents a kilowatt hour. And of course, off-peak is much less. But actually, here is winter pricing, which is 9.6 cents, and then summer pricing over 500 kilowatt hours a month, 14 cents. So the difference between the 9 cents, the 8.9 and the 9.6 is not as high as you might think. Note too that the peak times are 2 to 8 p.m. Off-peak is 8 p.m. to 2 p.m. the next day. Summer is defined as June 1 through September 30th, and of course all the rest of the time is winter. So that's the pricing. Now the unmanaged and managed charging scenarios involved unmanaged, being people could charge whenever they wanted, and managed meant that when their smart plug was installed, it was programmed to only charge between 10 p.m. and 6 a.m. However, everybody was shown how to program that smart plug so they could change it. Didn't matter if they were unmanaged or managed, they had the ability to change the programming on their smart plug. So we randomly assigned households to one of the two charging situations or scenarios. And so we ended up with 142 households distributed, as you see, through these 4-cell tables. And of course, that table, that design enables us to answer some important research questions. Now, I just want to touch on data collection so that you have a sense of really what was involved. We worked with Xcel Energy to complete the installation of smart plugs in study households. Now, they gave us those lists. I stratified them by zip code so that the vehicles would be placed around the city, and then people were randomly selected within those zip code lists. So they were pretty shocked when they got a call from me telling them that they were getting a package in the mail that involved a study in which the university would be providing them with a plug-in Prius for 9 weeks. So we conducted 284 face-to-face group interviews with family members because this was a household study and not a driver study. It's a household because you're plugging in the car, and now the car is kind of like an appliance. It uses electricity. So the household had to be an economic unit. It wasn't a household in which there were 4 students renting a house, sharing a house. It wasn't like that. 512 driver questionnaires, which we administered in person. And these were pre and post interviews and pre and post questionnaires. We also required them to write online diaries on topics of their choice. We had 142 sets of smart plug data in 5-minute increments for the electricity usage of the vehicles. 142 sets of 18 months of household electricity data in 15-minute increments. So this was 12 months before they got the car and 6 months after. And the utility bills for that same 18-month period. And then 102 sets of data logger data. This was because the cars didn't come with data loggers until May of 2011, so there were slightly fewer cases. And then just so you can get a sense of the length of time, it took about 3.5 months to get people through the process between the initial contact and the informed consent meeting to the post-interview. So as I said, we had 142 households with 265 drivers, almost equally distributed between men and women. And note that some of the data I'll be presenting is divided by household and some by driver, just so you watch that. There are notations at the bottom of the slides on that. 60 of the households already owned Toyotas, so Toyota had a pretty good reputation already among this group of people. And 32 households owned hybrid vehicles already. The number of vehicles owned per household ranged from 1 to 5, with a mean of 2.25. And there was an inordinate difference in the number of miles driven per year from 1,500, those are the people who were biking everywhere, to 50,000 miles. I'm guessing those might be the ones commuting to Fort Collins, for example. But the average was over 16,000 miles, which is higher than the national average. And the average of miles per gallon that they were getting from their primary vehicle was 25.5 miles per gallon.